What do you mean by this approximation? Approximations is generally used whenever the exact value of a particular number cannot be identified. So while doing these kind of sums, choose the nearest perfect square. So choose delta x in the form so that you will get back the nearest perfect square, or when you add or when you subtract it, you will get whatever is required. What is the derivative of y? It is nothing but dy by dx is equal to f of x. Hello everyone, a warm welcome to one and all. This is Yashruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So we are studying the applications of derivatives, and in this session we are going to study one more important applications of derivative, that is approximation. So what do you mean by this approximation? Approximations is generally used whenever the exact value of a particular number cannot be identified. So for example, when we have large number of decimal places, we'll approximate it to some of 3 or 4 decimal places. So what do you mean by approximations? So here approximation is anything that is similar but not exactly equal to something else. So for example, if you have 5.33639 something, we will approximate it to 5.35 here. So like this. So this is not exactly equal, but it is similar, almost equal to the expected value. So that is where the approximation of a numericals are used. And it is usually occurs when exact form or an exact numerical number is unknown or difficult to find. So whenever we need an exact value and it is not possible to identify easily, then we will approximate the values so that it will be almost near to the expected value. So this is where approximation used. So what is the necessary of derivative in approximation, or how we can use derivatives in terms of approximating the numerical values? Let's study it now. So here usually if I take y is equal to some f of x as some function, we know that change in y or a small increment in y is usually given by delta y is equal to f of x plus delta x minus f of x. So this is the increment in y which we use here. So let me consider a function from d to r, where d is a subset of r is the set of real number, given a function, and let y is equal to f of x. So as I said, since delta denotes the small increment in x, so now the increment in y is usually denoted by delta y is equal to f of x plus delta x minus f of x. So you can look at the graph here. So here we have the values here. So this is a point P of x comma y, and this one I have taken as dx, which is a small increment in x, and this is the small increment in y here. So now when this are all possible, we define the following. So the differential of x denoted by dx is defined by dx is equal to delta x. So here we take dx is almost exactly equal to, that is delta x. So this is the small increment. It is almost equal to the differential of x, that is dx. And the differential of y is denoted by dy, and it is defined by dy is equal to f dash of x into dx. Because we know that y is equal to f of x. What is the derivative of y? It is nothing but dy by dx is equal to f of x. So dy is differential of y, and this is f dash of x. F dash of x is derivative of f of x, and dx is the differential of x. Now, whenever dx is equal to delta x here, whenever dx is equal to delta x, that is the small increment of x is equal to the differential of x, we can approximate the value dy, that is approximately equal to delta y, and this delta y is given by delta y is equal to f dash of x into delta x. So this is what the delta y. Then how we are going to write? We write y as y plus delta y, where delta y takes the values of f dash of x into delta x. So the function is differentiated and the small increment in x is multiplied to get the small increment in y. Thus, when we add it to the given y, the result is nothing but the approximated value. So this is how we define approximation with the help of derivative. So here the very important thing is whenever dy is equal to f dash of x into delta x, suppose dx is almost equal to delta x, suppose they are equal, then the derivative of y can be approximated to delta y, where delta y is given by f dash of x into delta x. Now, let's see how to approximate these values with the help of the graph also here. So, here I have taken dx is equal to delta x. So, thus we can take the delta y, which is a small increment in y, can be approximated to dy. So, whenever these two are equal, we can take dy as delta y, and delta y is given by f dash of x into delta x, where delta x denotes the small increment of x. Now let us use these concepts in approximating the values in the given question. Let's move on to the first question. Using differential, find approximate value of root 49.5 up to 3 decimal places. So we have to approximate it to 3 decimal places here. So now here, so let me take here y is equal to f of x plus delta x minus f of x. So before that I have 49.5 here. So 49.5 can be written as 49 plus 0.5. So this can be expressed in the form of x plus delta x. So what is delta x? Delta x is equal to 0.5, remember. So 49.5 can be expressed as 49 plus 0.5, where we can take x as 49 and delta x as 0.5. Also, from the given question, we can take y is equal to root of x. So from the observed value, we can take y is equal to root x. So now here we have x plus delta x minus f of x. That's how I can write. Can write y is equal to root of 49.5 minus root of 49. So here f of x is nothing but y is equal to root x. So therefore x plus delta x means root of 49. X means root of 49. So I get, so here this is increment in y, so we will write it as delta y. Now delta y is equal to root 49.5 minus 7. So this implies root 49.5 is equal to 7 plus delta y. Now I need delta y. So what is delta y? Delta y is f dash of x into delta x. So f of x is here root x. So what is f dash of x? What is the derivative of root x? It is 1 divided by 2 root x into, what is delta x? Delta x is 0.5 here. So this is delta y. So now I have here delta y is equal to 1 divided by 2 root 49 into 0.5. So which is 1 divided by square root of 49 is 7, 7 2s are 14 into 0.5. So here we get it as 0.0714 and we can take one more values. So here we have 0.5. So this is delta y. So multiply it. So delta y is equal to, so we get delta y as 0.0357. So 0.0357. Now we got delta y. That's how we can add y. So now here look at this equation. Take this as equation 1. So we got delta y is equal to 0.0357. Add it to this value. So therefore root of 49.5 can be written as 7.035 I will write, because I need only 3 decimal places here. So 7.035 is the answer. Next one, using differential, Find approximate value of root 36.6 up to 3 decimal places. So remember 36.6 can be written as 36.6 can be written as 36 plus 0.6. So let me take this as x plus delta x. So this implies delta x is equal to 0.6. Now let me take small increment in y. Delta y is f of x plus delta x minus f of x. So x is nothing but 36 here. So f of x plus delta x means it is square root of 36.6 minus square root of 36, and here is we have delta y. So therefore square root of 36.6 can be written as 6 plus delta y. Take it as equation 1. Now we need delta y. Delta y is again it is nothing but f dash of x into delta x. So we have here f of x is equal to root 36. So therefore here we have y in the form of root x. So therefore what is y dash or dy by dx? It is 1 by 2 root x. Thus we have 1 by 2 root x into delta x. So this is our delta y now. So now delta y is equal to 1 by root x is nothing but square root of 36. It is nothing but 6. 2 into 36. So what is delta 6? That is 0.6. So now here we have 2 into 6. So therefore delta y is equal to 1 divided by 12 into 0.6. So delta y is equal to 0.083 into 0.6. So here we get delta y is equal to 0.0498. Now we got the value of delta y. So substitute in 1. So from 1, this implies square root of 36.6 is equal to, so here we have 6 plus 0.0498, which is equal to 6.0498. So again, if you can approximate, again you can take it as 6.0. So if you want to approximate here, you can write it as like this. So this is the nearest value or approximated value of square root of 36.6. Next, using differential, find approximate value of 25 to the power 1 by 3. So that is nothing but cube root of 25. So here y is nothing but cube root of x or x to the power 1 by 3. So here what I will do here, let x is equal to 27 and delta x is equal to minus 2. So then how we can write delta y? Delta y can be written as f of x plus delta x minus f of x. So this is nothing but your f of x here. So f of x is in the form of x to the power 1 by 3. So delta y can be written as here x plus delta x, which is nothing but 27 minus 2. So that is 25 to the power 1 by 3 minus x is nothing but 27. So 27 to the power 1 by 3. So while doing these kind of sums, choose the nearest perfect square. So choose delta x in the form so that you will get back the nearest perfect square, or when you add or when you subtract it, you will get whatever is required. So now you have here 25 to the power 1 by 3. So 27 or cube root of 27 is 3. And here we have delta y plus 3. So take this as equation 1. Now here I need a delta y. So delta y is equal to f dash of x into delta x. Now f of x is x to the power 1 by 3. So what is x to the power 1 by 3 derivative? So dy by dx will be n into x to the power 1 by 3. That is nothing but 1 by 3 x to the power 1 by 3 minus 1, which is 1 by 3 x to the power minus 2 by 3, or we can write 1 by 3 into 1 divided by cube root of x whole square. So like this we can write it. So here we get delta y is equal to, so I can write 1 by 3 into 1 divided by, so cube root of x. Cube root of x is nothing but cube root of 27 whole square, and delta x is here minus 2. So what is cube root of 27? It is 3. Now cube root of 27 is 3. 3 square is 9. 9 3s are 27. So this implies delta y is equal to minus 2 divided by 27. Therefore, delta y is equal to, so we'll get it as minus 0.074. Now we got delta y as minus 0.074. We can take up to 3 or 4 decimal places. Now let us substitute in 1. So this 1 implies 25 to the power 1 by 3 is equal to 3 plus minus of 0.074. So therefore, 25 to the power 1 by 3 is equal to 2.926. So this is the approximated value. Next we have here, find the approximate change in the volume V of a cube of side x meters caused by increasing the side by 2%. So here we need to find out change in volume. That is, we have to find out dV or delta V we can take. Change in volume can be taken as dV. We have studied in rate of change of quantities. That is, change of anything, we can write it in the form of d into u, d into v, or dp, dq, like that. So change in y can be denoted by dV for volume. Now, of side x meters caused by increasing the side by 2%. So therefore here we know that volume of a cube of side x meter is given by x cube. So therefore change in volume here can be written as 3x square into dx. So therefore here dx is a very small quantity, thus we can write it as dv is equal to 3x square into delta x. That is the increment caused. So here the increment of x is given, it is increased by 2% of x. So if x is this side, then it is increased by 2% of x. So that is means here they have given delta x is equal to 0.02 times x. So therefore dv is equal to 3x square into 0.02 times x. So this implies dV as 0.06. X into x square become x cube. So this is the change in volume whenever the side of the cube is increased by 2%. Next, if the radius of a sphere is measured as 7 cm with an error of 0.02 cm, then find the approximate error in calculating its volume. So here it is given, it's a sphere. So therefore, we have to change approximate error in terms of volume. So what is the volume of a sphere? Volume of a sphere is given by 4 by 3 pi r cube. Now change in volume is nothing but dV is equal to 4 by 3 pi r cube can be written as, since this is a variable, it becomes 3r square into dr. So dr is nothing but change in radius, and that change in radius error is given as 0.02 and the radius is given as 7 cm. So here we can see 3 can be cancelled. dV is equal to 4 pi. R is given as 7, so it is 7 square, and dr, error in radius, is given as 0.02. Now suppose if you take the value of pi as 3.14, if you have taken the value of pi as 3.14 here, so dV is 4 into 3.14 into 7 into 7 into 0.02. So that can be equal to 12.3088. So this is the change in volume or error in calculating volume we'll get. So this is how we are going to approximate the values given with the help of derivatives. We'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.